All right, today we're going to zoom way in, microscope level in, on the world of electronics. We're talking about those tiny, unsung heroes that make all of our favorite gadgets tick. We're going to pull back the curtain on one of these little components and see exactly how it works its magic. So, let's get into it.
Seriously, just think about that for a second. You've got this small battery putting out maybe 3 or 4 volts, but somehow it powers a flash that's blindingly bright? How on earth does that little battery punch so far above its weight? It seems kind of impossible, right? But the answer is actually really cool.
You see, the secret isn't about having a bigger battery. It's all about being way smarter with the power you already have. This is where clever power management comes into play. And the tiny component that handles this job is just a marvel of modern engineering. Imagine you have something like an electrical leverage tool. You put a small, gentle push of voltage in one end, and it multiplies that force to create this huge surge of voltage on the other. That is the core challenge. Designers are in this constant battle to deliver more power while sipping as little battery as possible and making less heat, all inside a device that has to fit in your pocket.
And that brings us to the star of today's explainer, a tiny chip that is an absolute expert at this exact task. So let's meet the right chip, RY3730.
So what is this thing really? Well, the RY3730 belongs to a class of components that engineers call step-up converters, or sometimes you'll hear the term boost converters. Their one and only job in life is to take a low DC voltage, like from a battery, and efficiently boost it up to a higher, more useful DC voltage. This specific little powerhouse comes from a company called RYCHIP. And these guys specialize in power management integrated circuits. Their whole focus is on creating these really innovative, really powerful solutions for modern electronics. And the RY3730 is a perfect example of what they do. Now, this chip isn't just some generic voltage booster. Nope, it has a very specific mission. It's purpose-built to drive strings of light-emitting diodes, LEDs. These are the very things that light up our phone screens and, you guessed it, create that brilliant camera flash. So what makes this little chip so darn good at its job? Well, to find out, we're going to do what engineers do. We're going to crack open the datasheet and see what's under the hood. Okay, just at a glance, we can see the highlights. It can handle a typical battery voltage, it can drive up to 8 LEDs all in a row, and it's packed with all kinds of protection features. But a couple of these specs, they have huge real-world implications. Let's break them down. First up, this number right here, 1.2 megahertz. That is its switching frequency. You can think of it as how fast the chip is flipping an internal switch to boost the voltage. And it's doing it over 1 million times every single second. So why does that incredible speed matter so much? And here is the brilliant payoff. A higher frequency means the other components that sit around the chip, we're talking about tiny coils and capacitors, can be physically smaller. In the world of smartphones and compact cameras, every single square millimeter of circuit board space is like gold. This is a huge win. Next, let's look at this figure, a feedback voltage of only 250 millivolts. Now, I know that might seem like some obscure technical detail, but trust me, it is directly tied to one of the most important things of all, efficiency. So here's the crucial point. A lower feedback voltage means less energy is just wasted as heat. See, in electronics, every little bit of power that doesn't become light becomes heat, and heat is the enemy. This one feature translates directly to a more efficient device and, most importantly for you and me, longer battery life. Okay, but talk is cheap. In the world of engineering, the proof is in the performance graphs. Datasheets use these charts to tell the true story of how a component actually behaves out in the real world. Let's take a look. So check out these two charts. They show the chip's efficiency under a bunch of different conditions. A designer uses these to find the operational sweet spot. For example, on the right, you can see how the efficiency, that's the vertical axis, changes depending on the battery's voltage on the bottom axis. The goal is to design the circuit so it operates in that peak efficiency zone as much as possible. And what about dimming the light? Well, this chip uses something called PWM control, which works by turning the LED on and off incredibly fast. The ratio of on time to off time is what our eyes see as brightness, and this chart shows that that relationship is a nearly perfect straight line. That means if a designer wants 50% brightness, they get exactly that. It's what gives us that smooth, predictable control, not some jumpy, flickering light. Okay, so we've seen the specs, we've looked at the performance graphs. Let's pull back and connect all these dots. Where does a chip like the RY3730 actually end up making a difference?
It really all comes together right here. You've got high efficiency for a long battery life, you've got the ability to use small external parts for a super compact design, and you've got precise control for really high quality performance. This combination is basically the holy grail for any portable electronic device.
And that brings us right back to our original question, doesn't it? The datasheet itself calls out camera flashes, digital cameras, and PDA backlights. Basically, the next time you take a photo in the dark or you see that vibrant screen on a handheld device, just remember, there's a tiny, powerful component, just like this one, doing all the heavy lifting, turning a little bit of battery power into a whole lot of light. And let's not forget the practical side of things. This quote points out that the tiny physical package of the chip doesn't just save space, it also helps save on the total bill of materials, or BOM, cost. For a company making millions of devices, that is a huge deal. They rely on specialized distributors like eBetter Company Limited to get these critical components exactly where they need to go, making sure the supply chain is just as efficient as the chip itself. So, the RY3730 is a fantastic solution for the challenges we face today. But it really leaves us with a fascinating question for tomorrow. As our devices get even smaller and somehow even more powerful, what's the next generation of these power management chips going to look like? What new tricks will they have up their sleeves? Now that's something to think about. Thanks for joining us for this deep dive.